This is Brian Putt. Today I'd like to talk to you about the value information distribution. So this is a pretty advanced topic, things that you probably haven't heard about before, but I think it can be very helpful in doing an analysis of value of information and in conveying the results to the decision maker. Value of information is a measure of the incremental value of new information. It could be appraisal work, it could be a test that's conducted. Pharmaceuticals do it all the time. There's only value in obtaining information if the information gained might change a future decision, and that value gained is more than the cost to obtain the information. So typically it's defined as the expected value asset value with information minus the expected value asset value without information. Just the difference between those two is considered the value of information. And in order to conduct a VOI analysis, you must know the decisions you're trying to make and the options that are available, the uncertainties that are involved, and what value measure you plan to use to make the decision. I want to talk about the distribution of value information relative to this problem description of the Abbey Winery in Napa Valley, which typically produces 12,000 bottles of Riesling wine each year when the proper balance of sugar and acidity are achieved. There is a storm approaching, and it has a 50% probability that it might ruin this year's crop. They can harvest immediately, and the wine will fetch $3.20 per bottle. However, if there's a warm, light rain, sometimes it will cause a mold, 40% chance, on the grape skins, and that raises the value of the wine to $8 per barrel, but reduces the volume to 70%. If harvesting is not done immediately and the storm arrives and mold is not formed, the berries get diluted, leading to a light wine will be sold at $2 per bottle. If harvesting is not done immediately and the storm does not arrive, the ripened grapes will either lead to good wine, selling for $3.50, light wine at $3, or acid wine at $2.50, and the probabilities are shown there. So what are the decisions to be made? Should the grapes be harvested now or wait if we want to maximize the value from this year's harvest? And should we pay $500 to get a better forecast of the storm? In summary, the wine values per bottle are shown here. So do we harvest now or harvest later? The answer is we should harvest later. It's preferred to harvesting now. Shown here in this graphic is the value if we harvest now is a flat $3.20 a bottle. And if we harvest later, we have this distribution. If the mold forms, we get the $8 a barrel and we have a really good outcome. On the other hand, if the mold doesn't form and there's a storm, we have to sell it wholesale. And in here is when the storm doesn't appear. So you can see that the value is $4,800 more by harvesting later. Therefore, the harvest later case is the reference case that we'll use for our value of information. I want to add that the analysis of the no information case is more fully developed and demonstrated in the video analyzing a model with SIPMAP. So, what if we could acquire information on the storm for $500? Is that something we'd like to do? So, there's some highly paid forecasters out there that cost $500. And they might be able to give us perfect information, as shown here on the right. And the question is, for perfect information, is it worth $500? And then the follow-on question is, if the information is imperfect, as represented by this table, is the information still valuable? So let's get into this. I'm not going to get into how we calculated the value with perfect information because this video is about the distribution of value of information, which we'll talk about in detail. Without information, we harvest later, as shown by the red line here. With information, we harvest later when there is a storm and harvest now when there is no storm. That means that 50% of the time we make the same decision of harvesting later, that is, the storm is predicted, and incur the $500 cost of the information. Remember, information only adds value when there is no storm and we harvest now. So what does the value of information distribution look like? Well, first of all, let's note that there's a difference in value here. The difference of 51 reflects the difference between the perfect information and harvesting later with no information. VOI is typically quoted as a single number, whereas in reality it is a distribution. Understanding the distribution provides insights why the information may add value. The decision maker may not just accept the difference of 51 on average and agree to pay the $500 for the information. The VOI distribution looks like this. It has an expected value of 51, which is what we saw on the previous slide, but it's broken down here into its components. So the upside of the VOI distribution is when there's no storm and we would have gotten acid wine by harvesting later. The downside is we did not forecast a storm, so we harvested now. But if we had harvested later, we would have ended up with good wine, and therefore it cost us money. We can see over here that 50% of the time, from a P20 to roughly a P70, we harvested later, consistent with a 50% chance of there being a storm. This probability here is when we predicted there would be no storm, harvested now, and there was light wine, because the light wine had a lower value than harvesting now. It gives us a positive value. So understanding the distribution can provide insights of why the information may add value. In this case, it only adds value 50% of the time. 50% of the time, it's actually losing $500. That's what we paid for the information. What about imperfect information? It does not add value. In fact, it has a negative value of $370. We harvest now 38% of the time. The distribution for harvesting later is shown in red here, and the distribution with imperfect information is shown in blue. It's really difficult here to tell what's going on other than the fact that there's two different distributions. However, if I look at the distribution of the value of information, as shown on the right here, we can see there's a big downside tail. And this is when I harvest now, and if I had waited, the storm would have generated mold on the grapes and we would have gotten the higher values. That's when I lose money. On the other hand, up here we predicted no storm, so we harvested now. And there was no storm, and we had acid wine. And here we got light wine, and here in this vertical part is when we harvested later, that 38% of the time, and we incur the cost of $500. Down here is we predicted no storm, so we harvested now, and if we had waited, we could have gotten good wine. So we lost money there. So what are the takeaways from this presentation? First of all, typically VOI is quoted as a single number, where in reality it is a distribution. Most of the time, the information will not change our decision. So the value is simply the cost of obtaining the information. And that by understanding the distribution, the VOI distribution, can provide insights and why the information may add value. I hope you found this video informative. Be happy to discuss it with you. You can contact me at brian@theputz.com. You may also want to look at some of my other YouTube channel videos. There are several on value of information and other topics. Thank you for watching.